Let's understand numbers. Number system as a topic is not very relevant in terms of the questions that have been tested in the recent CAT, but the topic numbers are very important for your overall, aptitude development. This video is designed as a part of the pre-recorded sessions for the CAT 24 batch. If you're willing to enroll into that batch, the description will have all the relevant links. Having said that, the agenda behind designing these videos are that you should be catered with structured videos with detailed explanation, as at the same time the exemplar problems that I am picking are the actual CAT previous year questions. Having said that, let's just delve into the session. So this session we are going to be typically looking at the types of numbers and their properties. We'll also understand the methods of counting the digital sum of numbers. We'll also understand the precedence of operations in arithmetic, something called as a V-BODMAS rule. And last but not the least, the types of questions that have been tested in exams like CAT, GMAT, GRE, and other aptitude exams. So let us start the session. The first thing that one needs to understand is the idea of types in numbers. So broadly speaking, there are two types of numbers: real numbers and imaginary numbers. Now, imaginary number as a topic is not relevant for CAT or any aptitude test for that matters. So I will not even discuss what these are, but let me just tell you what they are. Like, they can't be expressed in a number line, they can't be felt or experienced in the real world. That is all that you need to know about imaginary numbers rather. Real numbers, on the other hand, have a humongous application in the real world. So let us now understand what those applications are. So categorization of real numbers are also twofold. The first type of real numbers are called as rational numbers, and the other type is called irrational numbers. Okay. Now, you may want to ask at this point what exactly is so rational or irrational about these numbers. But to be very honest, the rationality of these numbers has to do with the fact that there is an element of ratios in these numbers. Okay. Now, whenever ratios are mentioned, we know that ratios is of a form P by Q. Okay. Where P and Q both are integers. Okay. What integers are, I'll explain in a while, but I'm pretty sure you guys already know what integers are. To give you a very brief idea of integers, they're integral number without a decimal part. Okay. So P by Q, form in which P and Q both belongs to integer and Q strictly not equals to 0, is the form of rational numbers. And by now you must have understood that irrational numbers can never be expressed in the form P by Q, and that is perhaps one of the reasons why they are called irrational numbers. Okay, we will get into the types of irrational numbers as well, but as of now, this is the difference between rational and irrational numbers. Okay, now at this point, because I have given you the idea of ratios, I should also seed in the idea, we will elaborate this on arithmetic, that this P by Q has a component of numerator. So P is the numerator and Q is the denominator, and any such number of the form P by Q where P is less than Q is a proper ratio. Okay, this is just a knowledge insight, you can just understand it. And where P is greater than Q is improper ratio. Okay, I hope this makes sense. There is something called as a mixed ratios as well, but we'll learn about that in a while. Now let's understand rational numbers in depth. Okay, rational numbers, the first kind of rational numbers are integers. Integers that are integral numbers without decimals in it. So for example purposes, I can say -2 as an integer, -100 as an integer, 0 as an integer, 10, etc. Now by the very examples you can see that integers can be categorized as positive numbers, negative numbers, and 0. 0 is neither positive nor negative. 0 is just right in there in the center. Another type of rational numbers, okay, another type of rational numbers that you will typically encounter is the type of decimals like this, in which the decimal part or a part of the decimal repeats till infinity. So in this case 5 repeats till infinity. Okay, this thing can be expressed simply by 0.5 and a bar over the 5. The bar over the number after the decimal represents the recurring part. This is also called as recurring decimals or repeating decimals as well, whichever you like to call. Now, fun thing coming at your way. Tell me, how is this even a rational number? Can you check for it? Can you convert this thing into the P by Q form? And the answer to that is yes, we can in fact convert this into the P by Q form, and 0.555 till infinity can be expressed as 5 by 9. Okay, now how exactly we have been able to express this thing, we'll discuss in a while. But every recurring decimal can be expressed in the form P by Q like this. At this point, I must tell you that all the repeating decimals with a fixed period are rational. And with that definition, let us try and understand what irrational numbers will be. So, can you check for me a number like 543481932, and this too goes on till infinity. And if you have paid attention, this number is an irrational number. There are no mathematical methods available to convert this thing into a ratio. And that is why this is an irrational numbers. Finite decimals like 0.48, 0. Let's say 7, these are finite. So finite decimals are rational numbers, but numbers of this type, which are non-repeating as well as non-terminating, these are irrational numbers. Okay, I hope that definition is clear. Now let's try and understand how the conversion method work, because we want to know how to convert a recurring decimal into a fraction. So decimals into fractions. And guys, if you want to enhance the video, you can switch to 1.5x speed. So let us say that there is a ratio, that there is a decimal given to us in the form 0. Or let's say 4.0 7285. Okay, let's take this as an example. Now, how do we convert this into the P by Q form? Whenever we are converting a number of this type, it is very easy. All we need to do is just multiply the numerator and the denominator by 10,000. When you do that, this 47285, when multiplied by 10,000 in the numerator as well as the denominator, this 10,000 in the numerator will take care of the decimal part, and this denominator is an extra bit that gets added. This is exactly what we have learned in school. We just get rid of the decimal and put as many numbers which are towards the right hand side of the decimal. This is exactly the logic behind it. Okay, at this point you can pretty much ignore this part and reduce this number further by taking out 5. If you take out 5, this will be 9457 by 2000. This is the P by Q form. Now, to represent a number in the P by Q form, it is not necessary that you get the fraction in its simplified or the simplest form. While solving questions, it may be required, but just to express a decimal in a fraction, it is not required. Now let us learn about a very interesting idea, which is the conversion of non-terminating recurring decimal as a rational number. Okay, these are rational numbers in fact, but as a P by Q form. So suppose the number is 0.3333, wherein this thing is repeats till infinity. Now this thing, as I had just mentioned, can be written as 0.3 over a bar. Now there is a shortcut, and I must tell you the shortcut is very quick to determine the conversion. But then, because this is a concept session, I'm going to give you the concept first and then I will give you the shortcut. So the textbook way says that you will let x as 0.3 bar and you will multiply 10 to the both sides. That will make it a 3.3 bar. We're just multiplying 10 throughout. Now if you remember, this is as good as this 3.3 bar can be written as 3 plus 0.3 bar, which is again as good as writing it as x. So 10x minus x is 9x, that is equals to 3, or in other word, x is equals to 3 by 9 or 1 by 3, whatever you wanna call. So this is a very longish method of conversion of this number, conversion of this decimal to this fractional form. But this is how you can do it if you forget the shortcut. Okay, this is what you have to do if you forget. Let us practice one more so that our understanding more practice. So let's say that we want to convert 0.345, and this time the bar is over 45. So this is as good as 0.3454545. Initially you will have to write it because then you will be able to understand the idea, and the same thing goes here also. So we will express the decimal as x 0.345. okay, now please pay attention that 2 digits are repeating, and because 2 digits are repeating, we will multiply throughout by 100. Okay, now this is an idea which you will have to use. When you multiply throughout, you will get 100x is equals to 34.5454 till infinity. Okay, now this part is going to be a little tricky because now you will have to break 34.5454 into two parts. The first part is going to be 34.2 and the second part is going to be 0.345. Now obviously this is very easy to understand. this part is designed so that we can get to that fractional part. How is it that we have gotten this 34.2? So very easy. 34.2 has been, we have been able to calculate 34.2 in a way that we get 0.345. Okay. Now obviously this thing is x and this is 34.2, that is equals to 100x. Hold on. So this is going to be 99x is equals to 34.2, or x is going to be 342 by 990. Now again, this is very lengthy and I don't expect any student to do this like this. So now we will learn the shortcut, and the shortcut is very simple. It's very elegant. It's just that you have to remember a couple of things. Okay. So I'm going to do the same question, but with the shortcut in mind. So the same question 0.345, and you can write this fractional form in one step, which is going to be, first of all, write the entire decimal part in the numerator, subtract the part which is not repeating. So here you can see 3 is not repeating, so that 3 is going to get subtracted. We are not subtracting 45, so 3 is going to get subtracted. We will put as many 9s in the denominator as the recurring part or the repeating part. So because there are 2 recurring in the decimal, we'll put 2 9s, and because there is a non-recurring part or one non-recurring part, we'll put a 0. 1 0 because of one non-recurring part. This is it. So this very easily gives you 342 by 990. So this is the shortcut. If you remember this thing, it's very important. It will be very easy. If you don't remember, then of course you can use the long method and convert. I don't think you'll get any question like that. Converting the recurring decimals to fraction, we just need to focus on the decimal part. If the entire section is recurring, it is very simple. Write the decimal part in the numerator and the recurring part, and as many 9s in the denominator. Okay, I'll repeat once again. Write the decimal part in the numerator and as many 9s as in the recurring part in the denominator. When some numbers are not recurring, we do subtract the non-recurring part from the entire section, and by section I'm calling it the entire decimal. And once that thing is done, the subtraction is done in the numerator, then again the same thing, put as many 9s as the recurring part and as many 0s as the non-recurring part. So quickly let's do another question to establish the idea. So let's do a question. So let us say that we have 0.12386 and the bar is over 86. That means 868686 is repeating till infinity. So we will do it like 12386 minus 123. Please remember that this is the part that needs to be subtracted from the numerator. We will put as many 9s. We will put as many 9s as the recurring part and as many 0s as the non-recurring part. So this is going to be 12263 divided by 99000. Now if I'm making any mistake in calculation, please ignore that because the idea is important. Okay, let's do one more last, just to distill the shortcut in our minds. Let's do one more. So let's convert 0.25 735, and this time 735 has a bar over the top. That means the recurring part is 735 735 till infinity. So how we will do it, we'll write the entire section 25735. Tell me which is going to be subtracted. The subtracted part is going to be this one, that is going to be 25, and then we will write as many 9s as the recurring part and as many zeros as the non-recurring part. Does that make sense? Now this is going to be equals to 25710 divided by 9990. Now at this point you can eliminate this thing. You can write it like 2571 by 999, and remember that this is the p by q form, although I will keep on saying this thing that the conversion does not necessarily require us to simplify. Okay, now let's do a question. The question is, if 0.142857 and the entire decimal section is repeating is given as 1.7, you have to find 3.142857, or you have to tell me what this number is going to be. Pause the video for a couple of minutes, try the question. So again the same thing, you will break 3 plus 0.14287, and because because this thing is already given as 1 by 7, you will write it as 22 by 7. Okay, at this point you can also write it as 3 whole 1 by 7, which is called as the mixed fraction. Okay, although this is not exactly p by q, but because we were asked to calculate for 3 point this thing, we have given you the answer, which is 22 by 7. Now before I end this video for this part, let me tell you the idea for irrational numbers, because in the next session we will be discussing irrational numbers. The very common irrational number, the most common rather I should say, is root over 2. This is actually called the Pythagoras constant. Okay, this is the most common irrational number. Pythagoras constant, this is called. Also let me tell you something, because just now we have received the number as 22 by 7, and the moment 22 by 7 is there, some of the students start thinking of it as pi. Pi is irrational. How it is irrational we'll see, but the idea that I am giving you in this part is that pi is the kind of a decimal that is non-terminating as well as non-recurring, and that is why it is a irrational number. And the equivalence that we use, 22 by 7, the value of pi is not at all equals to 22 by 7. It is just a approximation that we use for the pi. So that is it for this video.